Hello students, how are you? I hope you are doing good. So here we are with our question discussion on AIT 5 NEET question paper. So I have selected some problem for you, and we would see in this lecture some solutions, some concepts. Okay, so let's do it one by one. Right? So the very first question on your screen is a particle is released from rest at origin. It moves under the influence of the potential field U is equals to x square minus 3x. Its kinetic energy at x is equals to 2. So in this question, we have to find out the kinetic energy of this particle. So this question is from work energy and power chapter. And the concept that we are going to use in this, you can try to solve this in both way. Either you will apply the work energy theorem or you conserve the energy. So what we are going to do, we are going to apply the work energy theorem. So work energy theorem is work energy theorem. So what is the work energy theorem? Work energy theorem is the net work done is equals to the change in potential kinetic energy of the system. So initially we have an expression U is equals to x square minus 3x. If you want to calculate the kinetic energy at x is equals to 0, which means at rest. So you will see in the question, the particle is released from rest. So its initial velocity is equals to 0. If initial velocity is 0, this kinetic energy initial will be 0. If you talk about the initial potential energy, so put x is equals to 0 for u initial. So u initial is equals to 0. But the potential energy at x is equals to 2. X is equals to 2 pi. What is the potential energy? So put the 2 in this expression. So you will have 2 square minus 3 into 2, which results in minus 2 joule. Now, what work energy theorem says that work is equals to change in kinetic energy. Now we know that this is the uh, potential energy is defined only for the conservative fields. Okay. So in conservative field, the work done is equals to the negative of change in potential energy. So you can replace this work done by minus of delta U, and this kinetic energy will be delta K. So delta K is equals to minus of delta U. U you have already calculated. Delta U is nothing but U final minus U initial, and this is U final. So delta K will be minus of minus 2 plus 0. Sorry, minus 0, because initial kinetic potential energy is 0. So the change in potential energy is 2 joule. This is the change, but x is equals to 2 pi. We have to ask the what is the kinetic energy. So we know that at initial position, the particle is starting from rest. So you can put this delta K at K. So this is the kinetic energy at x is equals to 2. The correct option is option E. Okay. Now, this next question, a hemisphere of volume V is kept in a liquid of density rho. The vertical thrust on the hemispherical due to liquid outside it is. The vertical thrust is given by, in this situation, you will see that this is the a hemispherical bowl, which is just at the half of a sphere. So you will see at this curved surface, because this surface is open, there is water inside this. Okay. At this curved surface, the pressure would act radially to it on both sides. You will see. And it passes through the center of the sphere. Okay. So these types of question, what you have to do if the thrust is being asked and there is a certain type of body which is given to you inside the liquid. So you just have to calculate the liquid inside it. ठीक है. The liquid, how much amount of liquid it can hold, is able to put the thrust on this, because if this is the liquid present inside it, it has a weight and acting down. So this is the vertical thrust that is applied on this hemispherical ball. ठीक है. Now you know that the weight is the vertical thrust. Solution if I give you here. So concept is that always try to calculate the amount of liquid inside the system, I must say, or body. ठीक है. Okay. Now, so how much amount of water it can hold? The volume is given to you as V. Okay, and the density is also given to you. So mass is nothing but density multiplied by volume. Okay, got it. Now, the vertical thrust, if you see this component of pressure, it will have two components in this direction and this direction. This downward direction of pressure is the vertical thrust, which is nothing but the weight of the liquid acting downward. The weight is equals to given by mg, and you can put the value of m as rho v into g. So this is the value of vertical thrust. Look how simple is this. But you have to keep this in mind to calculate the weight inside the shape, and if the force is being asked or the pressure has been asked, just try to do the calculation. If the pressure is being asked, so force is being asked, so force is nothing but pressure into particular area. Okay. Now, move on to the next question. A sheet of area 40 meters square in used to make an open tank with a square base, then find the dimension of the base such that the volume of this tank is maximum. Okay. So a sheet of area 40 meters square is given to you. Okay. And we have to make a square base tank. Okay. You know that. And we have to make an open tank. So one of the end is open. So let's say this is the cuboid, or this is the tank that we have to make by this sheet. Okay. Or let me just draw it again in a bigger view. So this is the tank that we have to make, and we have to maintain this area, this base. This is the base. We have to maintain the base as a square sheet. So let's say, let us assume, and this is we have to made with a sheet. So this is the sheet we have. We have to convert it. The area of the sheet is 40 meters square, and we have to make it a tank of open tank with a square base. This base is a square in shape. Got it? Now, we have to calculate the maximum volume of this tank. Okay? Now, let us assume the base has an area, the base has a length x. So, this length should also be x, because this is the square. All the lengths are equal, all the sides are equal. And let's say this length is y, the height. So for volume, we are going to need this. So we are going to write the volume of this tank. So volume of tank is We know the formula for volume. It is a cuboidal shape. So length, width, and height, three dimension are to be multiplied. So volume here is, what is the length? You can take this x, width is x, and height is y. So it will become x into y. So volume you have as x square y. Okay. Now this whole tank is made up of this square sheet. This sheet, this is not square, but the area you know. So you can say that this tank has the same surface area as this sheet. Okay. So we will write this. The tank has same surface area as sheet. Okay. Now what is the surface area of this? You have a square and four other corners. 1, 2, 3, and 4. Okay. So surface area of this base is x square, x into x, plus surface area of this plane, it is x into y. Surface area of this plane is also x into y. This plane is also x into y, and this plane is also x into y. So we have four plane with a surface area of x. So what we are going to do, we have to write 4xy, and this all is equals to 40. This is equation number 2. Now we have two equation now. V is equals to x square y and x square plus 4xy is equals to 40. Now, what we are going to do, if we make the volume is a function of x, it is easy for us because y can be separate here. So put the value of y in terms of x in equation number 1. So y here is 4xy equals to 40 minus x square. Y here is 40 minus x square divided by 4x. So put this in, put the value, put in equation 1. So v here we have as x square into 40 minus x square divided by 4x. So x you have to cancel out. Now v as a function of x you will have as x by 4 into 40 minus x square. Okay. Now for maximum v, for maximum value of volume, what we are going to do, we are going to differentiate this volume with respect to x, and then we have to put it equals to 0. So dv of x by dx is equals to 0. Now if you multiply this x inside, this expression would be look like this. Vx is equals to, just a second, Vx is equals to 40 by 4 into x minus x cube by, or let's say you have to keep this thing out as it is. It is x by 4 40 minus x square. Okay. Now dv by dx is equals to d by dx of x by 4 40 minus x square. You take 1 by 4 outside because it is a constant quantity and differentiate this term. So you have 40x d by dx of 40x minus x cube. Okay. Now 1 by 4 d by dx of 40x will be 40 minus 3x square. And this thing you have to put 0. Okay. So 1 by 4 vanishes into 0. So it is 40 minus 3x square is equals to 0. So x you have as plus minus 40 by 3. Now we have to take only positive value. Taking positive value, because length could not be negative now. So taking positive value, x is equals to square root of 40 by 3 meter. So this should be the value of x, or the square base dimension. So option D is the correct option. Okay. So this is the dimension of the base. Got it? Now, in the arrangement shown in figure, so we have to find out the direction of force of friction is up the plane, or the magnitude of force of friction is 0. The tension in the string is 20 Newton, or the magnitude of force of friction is 56. Okay. So in this arrangement, a block and a pulley system is given. These are the most asked question. Okay. So in this scenario, a box is given to you, which is pulled or which is tied by a string, and with the help of a pulley, another block is also given. Okay. And this angle of inclination is 37 degrees. So for this types of question in which the condition has to be asked whether the block will move up or down, or it will remain stationary. So you have to see the net pulling force on the system. What is the net pulling force and what is the direction? Now if you will see, this is a block of 4 kg and the tension will be developed in this end. One thing is also here, that this surface is having a frictional value which is 0.7. The coefficient of friction is 0.7. Now, if I try to draw the FBD of this, so the net pulling force, if you will see, this will exert as mg, which is equals to 4g, because mass is 4 kg. And in this block, if you will see, the mass will acting downward, but you have to resolve it into mg cos of theta and mg sine of theta. Theta is given 37 and sine 37 is directly given to you. So you have to calculate the net pulling force on this. Okay? And that is why we are calculating this, because the net pulling force is going to decide the direction of motion, and the direction of motion suggests us that where should be the friction will act. Okay? So mg sine theta we have to calculate. M is 10 kg, G is also 10. Now, sine 37 is 3 by 5. For this also, mg is 4 into G, which is 10 equals to 40 Newton. So 10 into 10 is 100, 3 by 5. Now 5 to the 20, 5 to the 10, sorry. So 20 will be the result and it will give you 60 Newton. So on block, let's say this block is M1, this block is M2. So on block M1, force on M1 is 60 Newton and force on M2 is what? 40 Newton. So you will see that the net pulling force on the system is in this direction, because it exceeds the value of this one. So the pulling force will act in this direction. Okay? So what you can say, the magnitude of force of friction is 0? No, because there is a net force in the system, the block will start moving. So block will start moving this direction. If the block is moving in this direction, you will have a reaction opposite to that. This is the frictional value. Okay. So the force of friction will act upward. So option A is the correct option. We have find it out. What is the option correct? So force of friction will act in the upward direction. Okay. Now, In this question, the relation between time t and distance x is given to you. So we have to calculate the acceleration. So in these types of situation in which a relation is given to you, try to use the general equation of motion. General equation of motion. Okay, which is our ds is equals to vdt and dv is equals to adt, integration both of side, and these two equation you should use, and one equation is like a ds is equals to vd. This equation you can also use according to the purpose. So these three equation you should use when a relation is given to you. Okay. So we have to find out the acceleration of the system. Now t is equals to ax square plus bx. This is given to us. We know that acceleration is nothing but dv by dt, and dv by dt is nothing but dv by dt is nothing but ds by dt. If displacement is given in terms of s or x, whatever you are using, acceleration is d2s over dt square. But here the displacement or the position is given in terms of x. So we are using this as d2x by dt square. So it gives us a clear idea that we have to differentiate this particular relation with respect to time twice. So first dt by dt will be 1. So let me write differentiating with respect to time. Okay. So time is given to you. T is equals to ax square plus bx. Now this will become dt by dt. This expression will be 2 times ax, and then we have to differentiate x. That is dx by dt plus b into dx by dt. This is equals to 1, 2ax dx by dt plus b dx by dt. Okay. Now this dx by dt is nothing but the velocity. Dx by dt is equals to velocity. Okay. So 1 is equals to, you can take this dx by dt common. So you will have 2ax plus b into dx by dt, and we know that dx by dt is nothing but the v. So you have v is equals to 1 upon 2ax plus b. Now you have expression v is equals to 1 upon 2ax plus b. Now we have to again differentiate this with respect to time. So dv by dt is equals to, now this type of differentiation, you know, it must follow a formula, which is if you differentiate this term, let's say d by dt of 1 upon 2ax plus b. So it is a kind of 1 upon x type of situation in which x has a value of 2ax plus b. So 1 upon x will result in minus, what is the differentiation of 1 upon x? It will be minus 1 upon x square, d by dx of 1 upon x. How? Because this x goes up, so d by dx, x raised to the power minus 1. And we know the formula that nx raised to the power n minus 1 is the resultant of x raised to the power n differentiation. So it will be minus 1 into x raised to the power minus 1 minus 1. So it will give you minus 2. You can write it like this. Okay. Now we are going to use this formula in this situation. So it is, you will write it as minus 1 upon 2ax plus b whole square. But the story will not stop here. You have to differentiate this expression also, because itself this is an expression. So the differentiation of 2ax plus b you have to do, and this is called the chain differentiation. So the differentiation of 2ax is 2a and differentiation of b is 0. So you can say that it is minus 2a divided by 2ax, sorry, differentiation of x you have to write dx by dt, because it is happening with respect to time. Okay, so 2ax plus b raised to the power 2, and it is dx by dt is nothing but v, and we have known the value v. So it is minus 2a divided by 2ax plus b whole square into v की value 1 upon 2ax plus b. Now it is minus 2a over 2ax plus b whole cube. You can write it as minus of 2a 1 upon 2ax plus b ka whole cube. Now this 1 upon 2x plus b is nothing but v. So you can write that the acceleration of the particle is minus 2a into v cube. Now you can check the answer. It is option number C. Now, in a triangle of ABCD, the moment of inertia is minimum along axis through. So you know that the solution of it, that moment of inertia is given by m into r square. So it can be minimized, minimizing the value of mass and minimizing the value of the distance, perpendicular distance from the axis of rotation. So we have to arrange the mass such that along the axis, the minimum mass is there, or the lesser mass is distributed along the. So we should use this concept, lesser mass is distributed along the axis of rotation. And one approach you can use, that you can minimize this r. So the mass that coming into this situation should be placed nearer to the axis of rotation. So in this scenario, if you will see, this is the rectangle you have given. These are the possible axes. You can take this as axis. So this length would be, you will see, BC is 2AB. So it is AB, half of BC. This is also AB. If you take this axis passing through the centroid, then you will also have a length like this. Okay. If you take this axis, if you take this as an axis, this one, this axis is EG. So you will see in each and every situation, the distance from the axis of rotation of mass, the mass is only distributed up to AB ka half. This is AB by 2. So this is the minimum distance that we can have along this axis. If you check this one, if you check this AC axis, this is AC, you have a value of R pointing here, which is you can calculate by Pythagoras theorem, which is definitely greater than AB by 2. So this is not the possibility. You can take this axis as a rotation, but here you will see you have the length of mass from the axis of rotation is AB. So the minimum possible distance or the distribution of mass is along the EG axis. So axis EG is the correct option. Now, use the incorrect statement about the normal reaction. First is the normal reaction is perpendicular to the contact surface. So we draw a situation. This is the horizontal plane. The weight of body will act in this direction, and normal reaction is provided by this contact surface, which is always perpendicular to the contact surface. Okay. Now, the next point, this point is correct. Next point is when contact between two body break, the normal reaction vanishes. Yes, because it is a contact force. So when there is no contact, there is no contact force. So no, definitely the normal reaction will vanish out. Got it? This option is also correct. But we have to find the incorrect statement. Okay? So do not make this silly mistake. Just check the A. Okay? Now, okay. So option C is the weighing equipment except spring balances measure the normal reaction. Yes, of course. If you are standing on a weighing machine, only your normal reaction is to be measured. Now, this part, the normal reaction always passes through the center of gravity. It is not correct. Because if there is a curvilinear path and the body is here, so the body has a center of mass here, but the contact of this body, the contact force, normal reaction will act along the normal to this contact surface, not about the center of mass or center of gravity of this body. So this is the curve where this body has been placed. So the normal will pass through the circle of this curve because every curve is a part of circle. So this normal reaction would pass through the center of this circle. Okay? Of the radius of curvature. Okay? So normal reaction will also always pass through normal reaction will pass through the center of curvature. Because if the normal reaction always pass through the center of gravity, then phenomena like toppling is not possible. Okay? Now, if the surface tension, the question is given is if surface tension S, moment of inertia I, and Planck constant H were to be taken as the fundamental units, the dimensional formula for linear momentum would be. So this is from the unit and measurement. Now we know the fundamental physical quantities are 7. Okay, but in this scenario, the fundamental quantities has been changed. So it is changed by S, which is surface tension, moment of inertia, which is I, and Planck constant H. We know the dimension of surface tension. It is force per unit length. Force has a dimension of mlt minus 2 and length has a dimension of L. You can cancel out this L. So it has mt minus 2. Okay. The same goes for moment of inertia. Moment of inertia is mr square. M is mass. R is the length, which is given by L. So it is ml square. Now, the Planck constant, you have given this formula is equals to h nu when use the frequency. So h is equals to E by nu. Nu has a dimension of 1 by t per second and he has a dimension of energy which is ml square t minus 2 and it is 1 by t. Or you can say it is t minus 1. You take it upside, so you will have ml square t minus 3. So based on 3 dimension, this is dimension number 1, dimension number 2, dimension number 3, you have to calculate the dimensional formula for linear momentum. Now linear momentum is nothing but the mass into velocity. Got it? And mass into velocity, you know that mass is m, velocity is, but this is not we are going to. We have to replace this mlt with these given or changed fundamental quantities, which is S, I, and H. So one of the approach you should take, you could calculate you will take one option at each time and calculate the dimension of that. If it is matches with the linear momentum dimension, it would be a correct option for. Or you will try to do some mathematics and then find the solution. So only two ways are there to solve this question. So you will see key. If I just multiply this SINH, SIH, S has a dimension of mt minus 2, mt minus 2. I has a dimension of ml minus ml square, sorry, and H has a dimension of ml square t minus 3. Okay. Now, we need only one power of m, only one power of L on minus one power of t. Okay. So what you can say, if you just half the dimension of it, and you can take the half of it, then you will reach that m of half plus m of half will become m, completely m. This will reduce that minus 2 power to be minus 1, and this L square will become L. So the same dimension you will get. Only the problem which is created by this quantity. So you have to vanish this. So what you can do, you can take this power as 0. So here, if you will see that this would become MLT minus 1. So what we have do, we have take the dimension of S to be 1 by 2, take the dimension of I to be 1 by 2, and take the dimension of H to be 0. So now in resultant, it is S 1 by 2, I 1 by 2, H is 0. This is the dimensional formula for linear momentum now. So option D is the correct option. Okay. Now, a sandbag of mass 10 kg is suspended by a 3-meter long string. A 0.2 kg mass bullet enters the bag with a velocity 20 meter per second and gets embedded into it. The loss of kinetic energy in the collision approximately. So clearly you will see that the bullet will embed it into the sandbag, which means now they are moving together after the collision. So that type of collision is called as perfectly inelastic collision. Okay. So the collision here is perfectly inelastic. Inelastic. Okay. This is the bullet. This is the sandbag, and it's just embedded into it, and it will move with a certain velocity v. Okay. So what we can do in the collision, the momentum is always conserved. We can conserve the momentum. But since this is a inelastic collision, so kinetic energy, or you can say the total energy is not conserved. Okay. So that is why the loss has been asked. So firstly, what we have to do, we know the initial velocity of bullet. We want to calculate the final velocity of the system when it is embedded into it. Okay. So for that, we have to apply the conservation of momentum. So conservation of momentum. Conservation of momentum. Now, conservation of momentum is P initial is equals to P final. Now, initially only the bullet is moving if I consider it to be a system. So, initially only bullet is moving with a speed of 20 meter per second. So, it is m mass of bullet, which is nothing but 0.2 kg into velocity of bullet, which is 20 meter per second. Finally, When the bullet embedded into it, this sandbag will also start moving with the bullet with the same velocity. Now this system has the same velocity, the common velocity v. So we can say that finally 0.2 mass bullet plus 10 kg mass of this sandbag is moving together with the speed v, and that is the common speed. Now you will say that it is 4, it will become 4, it will become let's say 10.2 into v. So velocity we have here is 4 upon 10.2, or you can say it is 40 over 102 meter per second. Now, initially the kinetic energy, if you will calculate, only this bullet is moving. So kinetic energy is 1 by 2 times mass of bullet into velocity of bullet square, 1 by 2 mv square. So it will be 0.1 into 400, which is 40 Newton. Got it? Now, sorry, not Newton, it is in Joule. The dimension of energy is Joule. Got it? But finally, if you will see, finally, the kinetic energy final will become 1 by 2 times mass of the system, which is 10 plus zero point 0.2 into velocity of the system. And the common velocity we have already calculated, which is 40 by 102 square. Okay, so this will become 1 by 2 times 10.2 into 40 into 40 divided by 102 times 102. 110 has been cancelled out. 10 has been consumed by this point. So it will cancel out. And the final kinetic energy you will have as, let's say, let's just calculate in the next phase. So Kf is equals to 1 by 2 times 10.2 into 40 into 40 divided by 102 into 102. Finally, it will become 101 by 2. 102 multiplied by 4 into 40 divided by 102 into 10. Now, you can cancel out this. You can cancel out this also. So this will become 2 times 40 by 10 joule. Now, what is the loss now? Loss is the delta K, change in potential energy, which is K final minus K initial. So K final you have 80 by 102 minus initially you have as 40 joule. That is why it will become a negative quantity. So if you calculate this, just a second, if you calculate this, it will become 80 minus 40 into 102 divided by 10. So this quantity you have to calculate 40 multiplied by 102 minus 80. It will become 4000 divided by 102. So if you divide it by 102, this will result out in 39.215, which you can approximate as 39.2 joule. This is the loss of kinetic energy you will have in this system. Option D is the correct option. Now, in this question, a rod is given to you, which is initially hanged by a string at A. Now, what happens? We have just cut the string at point A. Now, the initial angular acceleration will be asked. Okay. So, what will happen in this situation? What will happen that this is the rod. Initially, all the mass or the reaction weight is acting downward. So this weight of this rod is counterbalanced by this tension, the tension in the string. But what happened? We have just cut this string. We have just vanished it. So this road is now, this end is now free to move. So it will rotate in this direction about this point, because this is the contact point. It will go up from here and down from. So initially the point of rotation is this point. Okay. And what is the responsible force for that? So it is the weight of the road. Okay. So we are going to calculate this. Now you can see here the road is rotating about this point, which is at L by 2 plus L by 4, or from here it is at L by 4 position. Okay. And from here it is at, from this free end is at L by 4 plus L by 2, which is 3L by. The weight is acting just in between. So this dimension is L by 4. This dimension is also L by 4. And this dimension is L by 2, which is given in the question. Okay. So force of weight, the weight force will always act at the center of the rod, which is mg. Okay. Now, this is the perpendicular distance of this force from the axis of rotation. So we know that that torque is equals to moment of inertia multiplied by angular acceleration. The torque is given by this mg. Torque formula is force into perpendicular distance from the axis of rotation, which is L by 4. mg into L by 4. We are interested in the magnitude. That is why we are not taking the direction. Okay. Now, I we have to calculate about this axis. Now, we are going to use the parallel axis theorem. The parallel axis theorem. Why? Because we just shift the axis parallel to the central axis. So in this scenario, we can use this parallel axis theorem to calculate the moment of inertia about L by 4 at this axis. Let's say this axis is B. So we calculate this IB, which is equals to, according to parallel axis theorem, center of moment of inertia about center of mass plus mass of the system multiplied by the distance from the center of mass. So it is L by 4, mass into L by 4 ka square. So this value we have to put it here. So it is mg L by 4 is equals to IB, which is I center of mass. Center of mass of a rod is given by, at center of mass, moment of inertia about center of mass is given by 1 by 12 of ml square. And it is 1 by ml square by 16. So put this value here. So it is ml square by 12 plus ml square by 16 into alpha. Alpha we are interested in. Okay. So what we are going to do, this is mgl divided by 4. We can take this ml square as common. So it will become 1 by 12 plus 1 by 16 into alpha. M and M got cancelled out. L will cancel out the 1 of the power of it. So it will become G by 4. We have take this L in this side. Now this, you take the LCM of it. The LCM of it will become, let's say 48. You will take the LCM. So it will become 12 4 the 48 and 16 3 the 48. So G upon 4L will become 7 upon 48 into alpha. You can calculate this with, you can cancel this 4 with this 48, which is 1 into 2, 12 for the 48. So finally, you have an expression as alpha is equals to 12G by 7L. So this is the correct option. So 12g by 7n is the correct option. Now, in this situation, this is an important question. From the top of a tower of height 40 meter, a ball is projected upward with a speed of 20 meter per second at an angle of 30 degrees to the horizontal. If g is 10 meter per second square, then how long will the ball will hit the ground? Time you have to calculate. So this is the, let's say this is the tower and the ball is shot from here at an angle of 30 degree and it will take this trajectory to reach the ground. Okay, so we have to calculate the time. Firstly, what we are going to do, we are calculate the time for this motion up to here because this is a paraboloid motion. Okay, and at that time we are going to see what is the time taken by this projectile to reach at the same level of the tower. Okay, and since we know this is a projectile motion, so we know the formula that time period here is given by 2u sine theta by g. Got it? So time period is here is nothing but 2 into what is u? U is 20 meter per second. Sine theta is sine 30, which is 1 by 2. We take the 2 in bottom side. Yeah. So you will have time as 2 seconds. But this is not the time of complete journey. It is a time from, if I take this point as A, this point as B. So this is the time from coming from A to B. Okay. We have to calculate the time for B to this point. Let's say C. We know this height is to be 40. If we know the velocity at this point, then it is simple for us to calculate the time. Okay. Now, what is the velocity? So according to the projectile motion, the velocity at this point would be the same for this point, the point of execution. So at point of execution, the velocity is 20 meter per second. So here the velocity will also see at the same level. Okay, got it? Now, so 20 meter per second is the speed you have. Okay, and 40 meter is the height in vertical direction. So if you calculate the vertical component of this velocity, which is the horizontal component is u cos 30 and vertical component is u sin 30. So same here, but the change in direction, u sin 30 and u cos 30. Why this change in direction occur? Because of the gravitational, okay, gravitational deceleration. So u sin 30 we have as, let's say, so we have to calculate the time for which this u sin 30 will cover this 40 meter. So we apply the equation of motion, which is s is equals to u, sy is equals to uy into t plus 1 by 2 times ay t square. Okay. Sy you are given is 40. Uy here is nothing but what? Uy is the u sin 30, which is u is given as u sin 30 is u is given as 20, sin 30 is 1 by 2. So you will have 10 meter per second. 10 meter per second into time that we have to calculate plus 1 by 2 times. This ay is also 10 into t square. To calculate this. Now, this will result in a quadratic equation, which is t square, sorry, 5t square plus 10t minus 4t is equals to 0. If you take the 5 as common out, so this will be t square 2t minus 8 is equals to 0. So 4 to 8 is the is the factor for it. So when you will calculate, you will have t is equals to -4 and +2. So minus time could not be in minus, so we will take this +2. So total time of journey will be time from A to B plus time from B to C. Time from A to B we have calculated as 2 seconds, and time from B to C will also be 2 seconds. So the total time of journey we will have as 4 seconds. Got it? So option B is the correct option. Now, in this question, this is the most general type of question from the friction that can be asked, a block over a block. So in this system, a body of mass 1 kg rests on a smooth surface. This is resting on a smooth surface. Another body B of mass 0.2 kg placed over A as shown. The coefficient of static friction between A and B is 0.15. So B will begin to slide on A if A is pulled with a force greater than. Okay. So we have to calculate the situation or condition so that the block will begin to slide. Okay. Now, what we are going to do, we have to draw the FBD of this. So if this block A will move in this direction, so this surface of contact will also move in this direction. But this block initially does not want to be slide on that. So there must be a friction acting in the forward direction of it. Okay. So this frictional force is on this block B, not on A. But in opposite to that, there will be an equal and opposite reaction. So if I draw the FBD of A, there will be a force F, and this will be the frictional force on this block A by the block put on the upper side of it, because the upper side is having friction. Okay. Now, if you calculate this for this situation, when this force F exceeds this value of friction, because this value of friction is limited, it can only go up to the limited friction value. So if this force is exceeded by this frictional value, then there is not enough friction to hold this block B at this position, and it will start sliding. Okay. So we have to calculate the force of friction for block A. So force of friction at block A is equals to mu into normal reaction on A. Now, in this, the mg force will also act. Mass of A is given by 1 kg. So only G will act in downward, 1 into G. And there will be a normal reaction, let's say N dash by the ground in opposite to that force. But here the one twist is there. This block B also exert a force on this block in the downward direction exactly at the weight of a block. This is the weight of this block, which is also acting as a force on this block A. So the mass of block is given by 0.2 into G. This is the force acted upon A by B. Okay. Now you in the normal reaction you can calculate. This FA is equals to mu is 0.15 into NA. NA is the net normal reaction. So N dash is equals to here 0.2 G plus 1 into G. Okay. So Na is nothing but N dash, which is 0.2 G plus G. So this will you have 0.15 into 1.2 times into G, which is 10. So if you try to calculate this, this will come up as, this will become 12 This is 0.15 and this will become 12. If you multiply it, you will get it 1.8 something. Okay? So 1.8 is the value of the limiting friction. So we have to exceed this value. So the force that is required is greater than this value, that is near about this 1.6764. It is the nearest value of this 1.8. So this force you have to must apply. So this force is greater than this value. So the block will start sliding. Now this question is from the fluid mechanics and you have to pay attention to it. So a metal block of area 0.10 meter square is connected to a 0.010 kg mass via a string that passes over an ideal pool, considered massless and frictionless. So a liquid with film thickness of 0.3 mm is placed between the block and the table. Now when released, the block moves to the right with a constant speed of 0.085 meter per second. Now the coefficient of viscosity we have to calculate out. The coefficient of viscosity is eta. Eta has a formula of, if you know the formula of eta, the coefficient of viscosity, it is shear stress per unit strain rate. Okay. Now we have to calculate the shear stress and calculate the strain. Now in this situation, if you will see, this mass will also acting in downward direction. The weight of this point mass or the block, which is 0.010, because this metal block, this is the metal block, which is connected to a 0.010 kg. So a reaction force has to be developed in the string also. There will be a tension in that string. And since this system is moving with a constant speed, so the acceleration is zero. If acceleration is zero, which means the net force is equals to zero. So you can directly say that this tension is equals to 0.01 into G. Got it? Got it? Okay. This tension will act in this direction to this block. And shear stress means we have to take the component which is parallel to the surface. So for shear stress, if I calculate shear stress is here is nothing but the tension divided by the area. Okay? Because the same tension is going to act on this block. Now, this tension you have calculated as 0.01 into G divided by, and G you have to take it as 9.8. Now, what is the area? Area is given to as 0.10 meter square. So from this you can say, you can multiply or you can divide it, so it will be multiplied by 10, or you will say that this should be, to remove this point we have to multiply by 100 in the bottom side, and to remove this point we have to multiply by 10 in the upper side. So this will be cancelled out. So shear strength you will have as 0.98 Newton per meter square, or Pascal you can say. Now for strain rate, strain rate is given by the velocity and this film thickness we have to. Got it? So it will be given by the velocity of the block divided by the film thickness V by L, which is 0.0, or let's say this is L. So this V is given as 0.085 divided by length is given you as 0.3. Now calculate this, put this both thing in this equation or in this formula. You will calculate eta as 0.98 divided by 0.85 multiplied by 0.3, because this will go in upside. So I have taken it as it is. Okay. Now, if you do the calculation, or let me just do it for you. So it is 9, sorry, it is 0.98 multiply with 0.3, 0.3 divide by 0.85. So it will result in 0.34, 0.345. Okay. So you can say, and this in this formula, this you have the in mm. So this length is to be multiplied with, it has to be converted into meter, so minus 3. So you can say that this will be the formula for that. It is 3 point, just a second, 3.45 to 10 raised to the power minus 3 Pascal second. Okay, got it? Now, so option B is the correct option. Okay, so it is not 0.85 here, it is 0.085. Yes. That is why this is come out as 3.455. Got it? Option B is the correct option. Now, in this question, to try to solve this, a ball is dropped from a height rise platform at t is equals to 0, starting from rest. After 6 seconds, another ball is thrown downward from the same platform with speed v. The two balls meet at t is equals to 18 seconds. So what is the value of v? So suppose this is the height platform we have, and one of the ball is just dropped. It is just dropped, and one of the ball is thrown with a velocity. Okay? But what is the change? What is the twist in this question? This ball is dropped at t is equals to 0, and another ball is dropped. Let's say I'm denoting it here. This ball is dropped at t is equals to 6, and they will meet at some distance from this point. Let's say this distance to be x at t is equals to 18 seconds. So the distance traveled by them would be same if they are meeting at same point. Okay. So we are going to use the equation of motion, which is, and we have considered this distance to be x. The equation of motion is s is equals to ut plus 1 by 2 times at square. Okay. We have to calculate the velocity. The time is given to you. The distance is same. That is why we are using this equation of motion, because most of the variable we know here. Okay. Now, the distance for ball, let's just name these ball. This ball is A, so, and this ball is B. So for ball A, what you can do, so x is equals to, the initial velocity of this ball will be 0 plus 1 by 2 times the gravitational acceleration is 10, which is given to us, into t square. Now this value of t is also given to you from 0 to 80. So x here is equals to 5 into 18 square. Now for ball B, x is equals to ut plus 1 by 2 times at square. U is given to you, initial, It is given to you? No, it has been asked. So it is V in this question. So we have taken it V. Time is 18 or something else. Yeah, that we have to focus. Because this ball is dropped after 6 seconds and they are meeting at 18th second. So the time taken by this ball to reach at the same level is 12 seconds. 18 minus 6. So this you have to focus. So time you have to take in here is 12 seconds. Plus 1 by 2 times acceleration is 10 and 12 square. Now put the value of x. It is 1 by 2 times 10 into 18 square is equals to 12v plus 1 by 2. 1 by 2 times 10 into 12 square. Take this on the left hand side. So 12v is equals to 5 you can take common. 1 by 2 times 5. 5 into 18 square minus 12 square. So common difference, square of common formula you can use. So it is 18 plus 12, 18 minus 12. 18 minus 12 results in 6. 18 plus 12 results in 8 plus 2 is 10. 1, 1, 2, and 3. So this is equals to 12b. If you calculate the value of b, it will be 5 into 6 multiplied by 30 divided by 12. 6 to the 12. 2 will cancel out this 30 will be 15 times. 15 5 the 75 meter per second. So correct option here is A. Okay. Move on to the next question. Solution. This question is also from fluid mechanics. So the work done in blowing a soap bubble of surface tension 0.06 Newton per meter from 2 centimeter to 5 centimeter radius. Now we know that in soap bubble there are two surfaces or interface. There are two interface or surface. One is inside and another one is outside. Okay. So you know that the work done it's doing against the tension is given by work done is equals to tension multiplied by the change in area. Since there are two surfaces or two interface at per surface, you will see here one is inside, one is outside. So you have to take the change of 2. So it is 2 times of change in area because 2 area will change. You have two surfaces. Change in area. Now T into 2 change in area. Initially you will have change in area is A final minus A initial. Okay. So tension you will have 0.06 into 2. Now change in area, the surface area of the bubble is or the sphere because bubble is a sphere. So the surface area of bubble is 4 pi r square. So you can take it as 4 pi r final square minus 4 pi r initial square. So it will become 0.06 multiplied by 2 into 4 pi you can take a common. So it will become r final which is 5 square minus. You have to convert it into meter because it is given in centimeter. Okay. So 5 into 10 raised to the power minus 2 whole square minus 2 into 10 raised to the power minus 2 whole square. If you do the calculation of it, it will be 0.06 multiplied by 2, or you can multiply this 2 with this. No? It will become 0.12 multiplied by 4 multiplied by pi into, you can take 5 square minus 2 square and take 10 raised to the minus power 2 as common, minus power 4, because 10 raised to the minus power 2 square will become 10 raised to minus 4. So it is 0.12 into 4 into pi. This will become 5 square is 25, 2 square is 4. So it will become 21 into 10 raised to the power minus 4. So if you do the calculation of it, if you do the calculation of this, it will result in 0.12 multiply by 4 multiply by 3.14, which is the value of pi, multiply by 21 is equals to, this will is equals to 31.651, 10 raised to the power minus. So if you take it, it will become 0.3003168 or 65, you can say. So it is matched by this option. So option B is the correct option. Now, in this question, a cylindrical rod is given to you, and you have to calculate the elongation of the rod. Okay? This question is from the mechanical properties of solid. So this types of question, you have to break this rod from the point where the internal force is being acting. So if you take the two part of this cylindrical rod, at this point, the 3F force is acting. So equal and opposite force will act in this direction. So in opposite to that, because these sections are not separate, these are joined with each other. So this, the opposite reaction to this 3F will also be here. But you will see that there is an internal force F, which is opposite in the direction of 3F. So it will result in 3F minus F, which is 2F. And that is why we have finally 2F. So suppose the elongation by 3F force in this is delta 1 and elongation by 2F is delta. We know the formula of elongation. So elongation is given by F into L, length of the object, divided by E, which is the E, or you can represent this by Y, the Young's modulus of elasticity, into area. So delta 1 we are going to calculate. So it will be, for this rod, it is F into length of this rod divided by Y would be same because the material is same, A1. A1 is also same because the same rod we have taken. So delta 1 here is F is 3F. L1 here is the length of this section. This is L by 3, so definitely it will be 12 by 3. So it is 2L by 3Y. It is 6F, or you can cancel out this 3. So it will become 2FL by YA. This is the delta 1. Now if you calculate delta 2, it is FL2 over YA. Now F is different for this. Let's say this is F1 and this is F2. F2 here is 2F. 2F into L2 is L by 3. 3YA. Now the net elongation, delta net, is nothing but delta 1 plus delta 2. So delta 1 plus delta 2 you will have as 2FL upon YA plus 2 by 3 FL over YA. You can take this 2FL over YA common. So this will result in 4 by 3. 1 plus 1 by 3 will become 4 by 3. So it will be coming out as 8 by 3 F over YA into L. This option D is the correct option. Okay. Now, in this question is from the circular motion. So car move in a circular path of radius 5. At one instant, the speed of the car is 5 meter per second and it is decreasing at a rate of 5 meter per second square. Now the angle between acceleration vector and velocity vector at this unit. Now suppose this is the circular track in which the car is moving. And let's say the car is moving in this direction. So the direction of velocity will be in the tangential direction. But this car is decreasing with the rate of, the speed of the car is decreasing with the rate of 5 meter per second square. So there is an opposite direction, the tangential acceleration will be. This is the AT. And a centripetal acceleration will act in this direction, which is AR or radial or AC you can say. Okay. So if you calculate, you do not need this data to be calculated over here. So we have to calculate the angle between acceleration vector and velocity vector. Now you can see easily that this AR and this AT are perpendicular to each other, 90 degree. So definitely, if we will see, you have to calculate the resultant of it. Now AR here is the AR is given by V square upon R. V square is given you as 5. V is given you as 5. So it will be 25. And radius of this curve is given as 5. So AR will be 5 meter per second. And AT is also given to you as 5 meter per second, decreasing in nature. So magnitude are same. You can calculate the angle tan alpha. Like this is the resultant in between them. Okay? And this angle is the alpha. So tan alpha here is nothing but, if you will see, so tan alpha here is 80 by AR. And this has 5 by 5, which is 1. So alpha is equals to 45 degree. You can clearly see the velocity. This is the velocity making an angle with this resultant we have to calculate. You can clearly see this angle is 90 plus alpha with the resultant acceleration vector A net. So 90 plus alpha is the resultant angle. So resultant angle we will see. Resultant angle between velocity and acceleration here is what? 90 plus 45 is equals to 135, and you have to convert it into pi. So you have to multiply it by pi by 180. And this will result in 3 pi by 4. Option D is the correct option. Okay. Now, this. So this question is from system of particle and rotational motion. In this question, what is the ratio of the radii of gyration of a circular disk to that of a circular ring, and each of same mass and radius around their respective axis? Which means the mass of ring is equals to mass of disk. Okay. We know that the radius of gyration, this is equals to mk square. This is the, and here k is the radius of gyration. Radius of gyration. Now, if you calculate it for disk, this is ID, this is for KD, mkd square, which is equals to, like, what is the ratio of radii of gyration of circular to the circular ring? Each of the same. So we know that the moment of inertia about this gyration axis is exactly equals to moment of inertia about the center of that party, of that body. So moment of inertia about center of mass of the disk. So it will give you a 1 by 2 m r of disk ka square. This is equation number 1. Now I for ring, which is equals to mass of ring. It is also mass of disk. Mass of ring into K of ring square is equals to I of center of mass of ring. So it is m/r ring square. Also, there is one information. This is mass and radius. Both are same. So radius of ring is equals to radius of disk. So you can take this ratio as like this will become 2 of mass of disk kd square is equals to mr d square. This is equation number 3. And this will become m mass of ring ka square is equals to mass of ring into k of ring square. Now, this, because radius of ring and radius of disk are same, so we can equate these two values. So you will have as 2md kd square is equals to mr into kr square. So you can calculate, you can cancel out these masses also because these are same. So 2 kd square is equals to kr square. Now you have been asked the ratio of radius of gyration circular disk to the ring. So kd by kr is nothing but 1 upon 2, and this has a square. So if you take the square on other side, it will become a square root. So you will have kd by kr is equals to 1 upon 2. The ratio will become 1:2. Option C is the correct option. Okay. So I hope you are clear with these questions, and it will be really helpful for you. Thank you so much. That's it. So if you have problem regarding the questions, please do ask and please try to contact. Thank you. Thank you so much.